Hey y'all, it's your math teacher, Mr. Boyd, and I'm back at it again today, and today we're going to be talking about the tangent ratio. And this is our intro into trigonometry, so here we go. Folks, what I have here is the exact text right out of our book, and it is lengthy and it says a lot. Let's try to focus just on the most important aspects, okay? And that's going to be this right down here, okay? All this stuff. I'm going to kind of highlight it in so you can see the really sort of, if you don't get this, then you're not going to get any of the concept at all type of stuff, okay? So this is the definition of what the tangent function is, okay? And the way we write it, and you'll want this in your notes, the tangent of some angle. So I'm going to make a note here because sometimes people forget this part and it gets really confusing for them later. The thing that we put here is always an angle. And then we have lengths, side lengths. So it goes the opposite side on top and the adjacent side on bottom. And so over here we can see our picture. So we've got our angle, and I'm going to introduce a new little symbol. It's theta. It's not a zero. So theta, that's a way of denoting an angle. And we've got our opposite side and our adjacent side. Now let's make sure we know what those mean. Folks, opposites, check this out. This angle right here, that's on the left side of the picture, right? What's the opposite of left? Right. And so this leg over here is on the right, and that's why it is the opposite. Okay, what does adjacent mean? Adjacent, essentially, a way of understanding it is it means that it's next to something. Okay, so I'm going to write in next to, and it's the one next to it. And you go, hey, it's next to it. But wait a minute. Isn't this one, AB, isn't that also adjacent to the angle? The angle's here, side's there, this side's there. Well, yes, that's true. Okay, it is adjacent. However, we don't call it the adjacent because we already have a different name for this side. Do you remember what that is? That is the hypotenuse. Okay, so we already have a name for that, so we're calling that the hypotenuse, and that's the adjacent. And then we have this shortened version here. I really like this shortened version personally. I'm going to use that a lot as I teach this. The tangent of A, the angle, is the opposite over adjacent. Okay, so that's going to come up a lot. Now let's try that with a visual. Okay, so we've got our picture here, and all we're doing is we're trying to set it up. What is the value of tan A? Okay, I'm going to go back. Hold on. Tan A is always a fraction, opposite over adjacent. So here I go. Tan A is a fraction. I'm going to find A on the picture. Which of these side lengths, the one that's 21, 20, or 29, which one's opposite from A? Well, A is on the right, 20 is on the left, so that's the opposite. Which side is the adjacent? Is it 21 or 29? Okay, well, they're both adjacent. We're going to say it's 21 because 29 is the hypotenuse. So I'm going to call that the adjacent. Okay, so 20 over 21. And y'all, that's done. That's the value of tan A. It's 20 over 21. What about B? Okay, we have to pay attention to where the angle's at. From B, B is on the top of the picture. Opposite of top is bottom. Bottom is 21. So that is the opposite side. Okay, and if you want to draw the arrows across the picture so you can see what's opposite, that would be fine. Okay, and then down here, we need the adjacent. What is adjacent to angle B? Angle B is here. The adjacent is 20. So we can see now it's just the flip fractions. Okay, that's just filling them in. Let's try one more. And this one, you may want to pause the video and try it on your own, okay? And so we're going to write it out like this. So pause if you haven't already, okay? So we get tan R. We need opposite from R. R is on top. Bottom is 47. So 47, there we go. And we need the adjacent, and that's 41. What about tan T? They asked us for tangent ratios of R and T. So tan T equals, it's a fraction. Opposite of T is 41. The adjacent then is 47, so 41 over 47 is going to be that tangent ratio. And y'all, that's all it is so far, okay? So we're going to get really good at setting these up. The next thing we need to learn is what algebra is required in order to start solving some real problems. Now, when I say real problems, I mean stuff like this. We're going to be asked to find missing side lengths and missing angles. And so what we're going to do is exactly what we've learned so far. We're going to start out, we're going to write tan, and the next thing we're going to write is an angle. Now look at this picture. What's the angle? The angle in this case is 54. Now I'm guessing a couple of you at home watching this, I'm guessing you probably said 90. And folks, yeah, there's a 90-degree angle. But here's the deal. This stuff only applies if we have right triangles. And so there will always be a 90-degree angle in a tangent problem, okay? Because it only is effective, at least at this level, it's only effective for right triangles. And so that's one of the reasons that we're not going to use the right angle. So for us, we're going to use 54. And I'll make that actually look like a 4. So 54 equals fraction. We always do opposite first, then the hypotenuse. Opposite side from 54 is W, and the adjacent side is 10. Awesome, we have the setup, but the question asks, what's W? Well, guess what? Now we're going to have to do a little bit of algebraic solving. And so I want to get W all by itself. The number with it is 10 and it's divided, so I'm going to cancel that out with multiplication. And here's what's neat about that, y'all. Now W is by itself, and that little guy right there is calculatorable. Now, calculatorable is a Boydenism, and all it means is you can type it in a calculator. So let's do that. Here I go. 10, 54, and I'm going to round to the nearest tenth. I get 13.8 when I type that in. So you may wish to pause the video, make sure that you know how to type that in, whether you're using your phone or an online calculator or a real calculator, whatever it is. Also, let's check. Does 13.8 seem reasonable or ridiculous for that side length? That's 10. This looks a little bit longer. Yeah, I think that's a reasonable answer. Okay, so that's what it's going to be. Okay. Now, people start to get a little bit overwhelmed with the algebra. So before we get into a bunch more exercises, I want to stop here and I want to make sure you understand that there are only 3 things that are ever going to happen in one of these geometry trig problems with the algebra. Okay. The first thing that can happen is exactly what just happened. Okay. Where we have something like tan 25, and folks, I'm making up the numbers. Okay. I'm just making them up so you can see what happens with the algebra, equals x over 7. Okay, and the algebra steps, when we have that, what we're going to do is we're going to multiply by 7. Last time it was 10, and then we're going to type that in the calculator and get 7 tan 25 equals 3.3. Okay, that is the first thing that can happen. Okay, here's the second thing that can happen. Second thing that can happen is instead of the variable being in the numerator, it could be in the denominator. So it could say tan 25 equals 7 over x. Okay, and people get a little frightened by this. It's not a big deal, okay? All we're going to do is when the variable's in the denominator, we're first going to multiply by the variable. That cancels it out here and moves it over here. And then I'm going to rewrite. I get x tan 25 equals 7. And I want x by itself, so what's in the way? Tan 25 is in the way, and they're multiplied, so I'm going to cancel that out with division. So divide by tan 25, divide by tan 25. And now, since that canceled out, I have an expression on the right that can be typed in the calculator. So I'm going to type in 7 divided by tan 25. And I get 15.0 when I do that. So x equals 15.0. Okay? So those are the first 2 things that can happen. Your variable can be on the top. Your variable can be on the bottom. There is one more thing that can happen. Like I said, there's only 3 things that ever happen in a tangent problem. Here's the third one. Sometimes you don't know the angle, so maybe it looks like this. Maybe it's tan of x equals 4/3. Okay, so this time the variable is the angle. And this is the one that a lot of people forget. So make sure your notes look really, really nice on this. Now, understanding here, we used an inverse. This was division. We used multiplication to cancel it out. We want to make tangent go away, so x is by itself. Well, what makes tangent go away? What cancels it? Technically, what cancels it is something called tan inverse. And you do it on both sides. Okay, and so now this says x equals tan inverse, or tangent inverse, of 4/3. And it looks like it's the negative first power, and symbolically that's what it is, but the way we say it is tangent inverse. And you actually have this button on your calculator. Now, if you're in my actual classroom, what you do is you hit the shift button first. If you're not in my classroom and you have your own calculator, sometimes you have to hit the second button before hitting tan. And a lot of times, like on an iPhone or a Samsung phone, that's the button we have to hit first. So then that notifies the calculator, hey, we're finding an angle. So here I go. So I hit the second button, and then I hit tan, which brings up tan inverse, use parentheses, 4 divided by 3, and close your parentheses, and I get 53.1. And the one thing I want to remember, that thing's an angle. I just found an angle, so that's degrees. Oops, didn't mean to put that second mark there. Let me get rid of that. So 53.1 degrees. Okay, and I want to add one phrase to that, and that is exactly this, y'all. That's the inverses, meaning that little guy right there. Inverses find angles. Now, I've had some students in the past say, I'm not going to worry about the inverse. I'll just type tan in the calculator. It'll be fine. Folks, that doesn't work, okay? When you hit the tan button, your calculator is thinking that it needs to tell you a side length. And so if you're looking for an angle, but you hit the regular tan button, you're going to be disappointed with the answer. It's not going to work for you. When you hit tan inverse, you've now notified your calculator, hey, calculator, I want you to tell me an angle, please, and then it'll actually tell you an angle and life will be good. Now, the reason I spent time showing you these three things is whenever you have a setup, because you're already good at getting the setups, whenever you have a setup and you start to feel overwhelmed, I want you to look back at this and say, oh yeah, that's right. There's only three things that can ever happen with these. If you can then categorize which one you're doing, your questions become very, very easy to answer after that, okay? So functionally, let's see what this math is for and let's get good at it, okay? It can be good for answering questions like this one, where you need to find the height of a tree. I'm sure you can imagine a situation where it's not safe to actually measure how tall a tree is. But if you can measure the angle and you can measure how many steps away from the tree you are, you can actually figure out how tall it is. Okay, so let's go for it. Here I go. I'm going to say tan. We already learned the next thing we need to write is an angle, so that's 32. And then that equals the opposite over adjacent. Where's the opposite from 32? Well, it's the tree. Now, folks, if you like variables, put an X there or a T. I'm actually going to write tree. Okay, and that's my symbol for it. Okay, I'm calling that the tree. Totally legit to do. And we said opposite on top, adjacent on bottom. That was the original definition. So 125 goes on the bottom. Now see if you can figure out what the next algebra step is. We want to know what the tree is. So we need to get tree by itself. Does that fall into case 1, 2, or 3? Okay, this is an example of case 1 because the variable is on the top part of the fraction. You see that? Right here, variable's on the top part of the fraction. That means we need to multiply on both sides. So I can type in 125 tan 32, and I get 78.1. And that's the tree. Now, 78.1, what? Miles, meters, feet, degrees, hours? What is it? Okay, this was in feet. So the tree is 78.1 feet tall. Okay, and that's a reasonable height for a tree. Okay, it looks like we got it. Let's do another one. Okay, this one we're finding an angle. Ooh, inverses find angles. Okay, we got this, y'all. Let's do this. Okay, so we're going to say tan of the angle equals the opposite, 4, over the adjacent, 5. And then all I'm going to do is type in tan inverse of 4/5 in my calculator. So here I go. Watch how quick this is. Tan inverse 4 divided by 5. And I get 38.7 degrees. And that's done. That's all it is, okay? Let's do a couple more. Okay, here's another one. Pause the video. You try this one because I'm about to get going. And if you don't pause your video, you're going to spoil the answer. Okay, go for it. Okay, on this one, all I'm going to have is tan of x equals 11 over 8. And then I'm going to type in tan inverse of 11 divided by 8. And I'm going to get 53.97. That's 54.0 degrees. And that's it. Okay, almost done. Two more. Okay, on this one, I want to find the number of degrees in all of the angles. Okay, I already have two side lengths. I want to know the angles. So let's start with this one. Okay, and I'm just picking one arbitrarily. So I'm going to say tan of P equals the opposite, 41 over 100. I can type in the tan inverse of that then, because inverses find angles. Remember that. So 41 divided by 100, and when I do the tangent inverse of that, I get 22.3 degrees. 22.3 degrees. Awesome. Now, I want to find this other missing angle, and I want to do that as efficiently as possible. Could you use tangent to do that? Sure you could, but I remember that every triangle has 180 degrees, so minus 22.3 minus 90, and what do I get? I get 67.7 degrees. Okay, let's do one more. Okay, and that would be this one. Probably want to pause the video, try this one on your own, okay? You're going to need a minute to draw down this picture, I think, so go ahead and hit pause now. Okay, once you've played again, here's how it goes. Tangent of x equals 5 over 7. Use tangent inverse, and that means that we have an angle of 35.5 degrees. Okay, over here, we're going to say tan W, because we're only looking at one triangle at a time, right? Now there's 3 triangles on there, only look at one at a time. Okay, we want our opposite first, so 5 over 3. And here we go. Tangent inverse of 5 over 3 is 59 degrees. Okay, 59.0, I'm going to call it 59. Okay, so that's W. I should probably say W equals, like a good little mathematician should, and I have x there. So folks, after this short intro, you've already got a pretty good idea of how the tangent function works. Okay, it's useful for finding sides, useful for finding angles. Next time we're going to learn about sine and cosine. It's going to work largely the same way. It's just one new little wrinkle in this stuff, so I think you're going to do great. Okay, hope you enjoyed this video, and we'll see you next time.